Today we will examine the Thistle landslide. To do this, it is needed to jump back into time to 1983 and transport to Utah County, Utah. Luckily, this landslide did not result in any deaths, but did result in the displacement of a community as well as over $200 million of damage. The slope that eventually failed had measurements of small movement that started as far back as the 1900s. Years that had above average rainfall and snowfall were correlated to years that motion was measured. Leading up to the 1983 event, the region received not only above average precipitation in that year, but also in the year prior. 1982 had record-breaking precipitation in the fall, and the winter of 1983 had an especially deep snowpack. A warm spring followed the winter, and snow quickly melted. These factors compounded to cause the groundwater levels to rise, saturating the soil. The presence of highly saturated soil caused the density of the soil to increase, increasing the amount of shear stress that the slope had, which eventually in 1983 overcame the shear strength of the slope, causing failure. The landslide contained enough water to be considered a debris flow, and when it stopped, it had buried 3 highways, 1 railroad line, and created a debris dam, which later filled to become Thistle Lake. The lake filled, flooding the town of Thistle. The lake was later drained in efforts to mitigate the potential of the dam breaking and causing more damage. This translational landslide was massive, with over 1,000 feet in width, nearly 7,000 feet of length, and 200 feet of depth. Although nothing as large as this event has happened since 1983, failure events have continued to happen in the area since 1983, with high saturation of years, showing that slopes have relatively unstable factors of safety, seeing that they easily become unstable with saturation.